Good morning, I'm Greg Jansen, recording this on November 10th in North Carolina. I'm presenting today on behalf of my colleagues, Richard Marciano, Lenice Williams, and Mark Conrad. We're at the Advanced Information Collaboratory at the University of Maryland's iSchool. I'll be presenting on our work on a digital asset management system for the National Park Service, in particular the archives of the Mary McLeod Bethune Council House historic site in Washington, D.C. And these include the National Archives of Black Women's History, very important collections that are especially relevant today. This presentation may interest you if you have a need for archival digital asset management, preservation and curation of archival materials, if you have a need for high throughput digital repositories, in particular based on linked data, also Fedora-like repositories. This may interest you for those reasons. Thank you for tuning in, and I'll get started. So first of all, we wanted to say that we are very proud to be working with the collections of the National Archives for Black Women's History. These were pioneering women at the forefront of the struggle for civil rights, and there is a rich archival context here of overlapping organizations, their members, programs they had, projects and events, and all documented in photos, correspondence, minutes, and audiovisual recordings. And you have to take that alongside the public information, such as newspapers at the time, government policies and legislation, and all manner of things out there around these struggles. So DRASTIC stands for Digital Repositories at Scale that Invite Computation. It's been presented here as part of our research in previous CNIs twice. Thank you very much. And it's just an ongoing research initiative in our group at UMD to explore the possible futures for digital archives, digital repositories, and digital asset management systems. At the National Park Service, the digital asset management system has to fit into existing systems and workflows. So this diagram shows, in particular, the vendor digitization system or workflow that produces image files and Excel metadata. It shows the integrated museum catalog system and their photo gallery system. So as a DAMS, it can function and fit in within these other systems, but it also can serve in a extract, transform, load role, ETL, and be used to funnel content into other systems, such as the photo gallery. We wanted to design this system so that it could leverage existing workflows instead of creating new ones. So one of the things we wanted to do is when vendor digitization workflow, for instance, delivers a bunch of data, a bunch of files and images, we want to use them as they are. We want to pick up what they put down and not require a lot of adjustments to files before ingest. The digital asset management system has a flexible ingest system or content acquisition system. There's a web application with a drag and drop workflow. You can take files from your desktop and drop them in your browser onto the page, and it will ingest into the repository. Also, any submission folder in the DAMS can be presented as a network drive, making it easy to use normal desktop tools and put your output files into the DAMS directly via a folder system or file explorer. And lastly, nothing prevents you from creating your own custom ingest tools or pipelines around the Linked Data Platform API. So many existing tools that have been created around the Fedora 5 specification, for instance, will also work in LDP, Linked Data Protocol. So you can reuse those systems, those tools, to perform ingest on this DAMS. So when you drop a file into the digital asset management system, you're dropping it into the linked data platform implementation called Trellis. And Trellis was developed by Aaron Coburn for the libraries at Amherst College. And he now continues to develop it for Sir Tim Berners-Lee at Inrupt.com, where they're working on implementations of the social linked data project, SOLID. And so, as it happens, Trellis does support the SOLID specification as well. In a previous DRASTIC research project, we helped develop the Cassandra storage model for Trellis and tested the performance of Trellis and other Fedora implementations and other linked data platform implementations at scale. So when you drop a file into the web interface, it travels via linked data protocol into Trellis and on into an Apache Cassandra database cluster. Cassandra then distributes redundant copies of the data into different servers. And I might mention here that Trellis is a stateless server. And so you can start as many Trellis servers as you want, as you need to meet demand. They don't need to coordinate. And Cassandra clusters provide very high throughput reading and writing of data and can also scale up to meet demand or create more storage capacity. So overall, this is a very elastic and cloud-ready architecture to store a whole lot of digital assets. Right, so our assets are stored in the system. What then? What happens next? First, for this archival application, we want to establish the fixity of the asset by calculating an MD5 and a SHA-256 digest. Then second, the system will fire up services that begin to inspect each file that was dropped to see if we can glean more information. In the national parks case, Excel spreadsheets are used for metadata and manifests in the digitization workflow. And these files are already lying around, and we have taught the DAMS to interpret them. So the DAMS makes item level Dublin core linked data from one of these spreadsheets and makes some file level premise fixity linked data from the manifest spreadsheet. Then another service validates that the two fixity values match each other. That is the one that's calculated upon ingest and the one that was calculated previously by the vendor. And then another service makes access images and thumbnails of the original image. And lastly, a service looks at the file names of the images, which follow a naming convention, and uses that to construct a page document model for each item. So 5 files go in, and the result is that 7 new files are created, and 2 new linked data graphs are created, and a sprinkling of fixity information is overlaid on the original files. So that's a lot of services running, and that's just the beginning. We want to add many more services. So we think a modern digital asset management system has to support such sophisticated workflows and read-write throughput that those services might demand. Since they're firing off and triggering all the time and modifying content quite rapidly, you need some high throughput in your backend. Services in this DAMS environment can run anywhere and in any programming language. I mean, you wouldn't want to run them anywhere, but in independent servers, or you can co-locate them on a server. But they are all triggered by modifications to the assets in the DAMS, and that happens via Kafka event streams. So Kafka libraries are available in any most programming languages, I shouldn't say all. And the linked data protocol that the services need to use to interact with the server, the DAMs itself, is HTTP, it's RESTful, it's Linked Data Protocol API. So whenever you create, update, or delete some content in the DAMs, one or more services can just respond to that event coming from Kafka. And Kafka is a fault-tolerant distributed eventing system that is widely used in web-scale applications. So Kafka will also be the best way to trigger any integration behaviors around the DAMs in systems outside of the DAMs if that's something that you also require. We also rely on Kafka to update the user interface for all connected clients. So if a user is using a browser to view an item and that item has changed because some other user has made a change, their view will be updated in real time. And this happens through a WebSocket connection between that browser and the Trellis server that it's speaking to, which also comes to the Trellis server via the Kafka event stream. So despite being highly distributed and multi-user, this system can display items to many users and have them all updated in real time. They're never stale with respect to what's in the Cassandra database. I've talked a bunch about the systems behind the scenes so far. So here you can see the DAM's user interface, or part of it. This is the asset management interface. And we will be building an archival access interface for the materials this year. And this is a good time to share my metaphor of an archival stew, since we're looking at a bunch of data. We've put a bunch of data in our pot, and we are starting to cook it in a broth of services, if you will. And the flavors are starting to come out of the ingredients and meld together in a sauce that we call enriched archival context. It smells great. It's really tasty. But if we overcook the stew, I think the flavors will become indistinct and we'll be left with a muddle of linked data. Maybe I've taken this too far, but I think that the way to prevent an overcooked stew is to maintain provenance for your linked data. So in this repository, and I think in others like it, Linked Data Protocol gives you the ability to separate your linked data into named graphs that are like small independent databases. Then you can record information about each graph and attribute the linked data within to a particular user or service. It can be versioned. You can see who modified it last. You can even tag named graphs as crowdsourced or needing review. And in this way, we can create a lot of linked data and still keep a decent handle on things. Now we turn to another type of prototype, that of the enhanced archival context. Mark Conrad and Lenice Williams looked closely at particular items in the National Archives of Black Women's History, including correspondence and photographs. They extracted the relevant metadata by hand and into spreadsheets and created a graph representation of the archival context using a tool called Neo4j. In this diagram, you can see photographs in blue and people in orange and correspondence in green. Then the various links show how the items and subjects are related to each other indirectly and directly. You have relationships for correspondence received and sent, and who appears in which photographs. The names in this diagram have been changed since we did not seek permission to disclose the real data. This work prefigures the linkages and cross-references we can expect to find and navigate in an enhanced archival context. Thank you so much. We owe a special thank you to the National Park Service and the Capital Region for making this work possible. We have another year ahead of us, and in that year we are focused on providing an enhanced archival access experience. We hope that this work will be useful to others looking to adopt similar technologies for their own collections. If you'd like to hear more about this platform and our current research, you can reach out to me, Greg Jansen, at jansen@umd.edu, and we very much like to hear from you. Thanks very much.